and the outer edge of the galaxy.
Gonzalez, Brownlee, and Ward labeled this region, where complex life is possible within the Milky Way, the galactic habitable zone. Their theory was first published in 2001 and has since received growing acceptance among astrobiologists.
There's a lot more research that needs to be done to determine just how wide the habitable zone is, but I think there's general agreement that yes, there are definitely places in the galaxy that you cannot have civilizations because they're very dangerous, and there are places where you just have a very low abundance of heavy elements.
While these obstacles to habitability are minimized far from the core and edge of the Milky Way, Gonzalez has also identified large areas within the galactic habitable zone itself, which are less hospitable to complex life.
Even within the habitable zone in the galaxy, it's broken by the spiral arms, which are dangerous places. That's where most of the supernovae go off in the galaxy. That's where the star formation is taking place.
We don't want to be too close to a spiral arm. We want to be outside the spiral arm at about the right region of the galaxy.
It appears this is precisely where the Earth is located, in the relatively safe and uncrowded region between the Sagittarius and Perseus arms of the Milky Way.
Location is everything, and so we occupy that special place in the galaxy where habitability is optimized, threats are minimized, and we have enough building blocks to build an Earth.
Guillermo Gonzalez and Jay Richards have conducted research on another facet of the galactic habitable zone. They now argue that the Earth is also located in the best setting within our galaxy for astronomical research.
As it turns out, our position in the universe is not only critical for life, but it's also surprisingly important for making scientific discoveries. We're located near the midplane of the galaxy, a very highly flattened galaxy, between spiral arms in a region with very low dust extinction. While we are in the plane of the galaxy, that does not obscure a large part of the sky, so we can have very clear views.
For more than a century, this nearly ideal platform of observation has enabled astronomers to study the structure of the Milky Way. Looking toward the constellation Sagittarius on a clear night, for example, we see that the stars in our galaxy are not uniformly distributed across the sky. Instead, they appear as part of a concentrated band, a flattened disk of stars, dust and gas, 100,000 light-years in diameter.
The Milky Way band in the night sky is us looking edge-on into the plane of the galaxy. If we were living in the center of the galaxy, things would look much more spherically distributed. And so it would be very hard to distinguish things that are inside the galaxy from things that are outside. And it's also very dusty, much dustier towards the galactic center than it is in our region. And so the views of the distant universe will be much more difficult to obtain, to be much more compromised.
Similar problems would exist for astronomers working on a planet located within any of the galaxy's spiral arms. Here, denser concentrations of dust clouds and gas illuminated by stars would make it difficult to determine the shape of the Milky Way, or to distinguish the stars in our galaxy from the rest of the universe.
On the surface of the Earth, we're really in the optimum position for seeing both the nearby structure of the Milky Way galaxy, as well as seeing the distant cosmos as a whole. So once again, we see that the best location for habitability and for producing a habitable planet is also the best overall position for scientific discovery, in this case, at the galactic scale. For centuries, the fact that we can discover things about the universe has really been something of a mystery. Why would beings like ourselves be able to discover a universe like this? Why is what we think about the universe, why would it correspond to the way things really are?
Our ability to discern and understand the universe is a fundamental part of what makes the universe tick, so that we're linked into it. This isn't just a sort of an accident, a trivial little byproduct. It is something that is linked to the great cosmic scheme of things. Now, I've no idea how that linkage works, why it's there, or anything of that sort, but I'm very, very struck by the fact that we can understand the universe in such exquisite detail and at such a deep level.
The spectacular progress of modern astronomy and physics is the product of a universe accessible to the human eye and mind. It is a universe governed by laws and forces that literally hold our planet Earth and the entire cosmos together, and are finely calibrated to allow for both complex life and scientific discovery.
If you didn't have something like gravity that pulled matter together, you would never get planets, you wouldn't get stars, you wouldn't get any complex organisms. If you didn't have the strong nuclear force, there would be nothing to hold protons and neutrons together in the nucleus. And so you wouldn't have any atoms, so no chemistry. If you didn't have the electromagnetic force, you would have no bonding between chemicals. You would have no light. And the list goes on. So you need all these sorts of fundamental principles have to be in place in order for life to occur. Wipe out one of those principles, wipe out one of those laws, no life.
During the past 40 years, scientists have determined the relative strengths of each of these primary laws and forces. These strengths are so critically balanced, they are often described as being finely tuned.
If you're to take the basic fundamental constants of nature and you were to change these even slightly, or you were to pick their values at random, you would almost never get a universe that would be habitable in any sort of way. That is, you couldn't have galaxies, you couldn't have planets, you couldn't have complex biological organisms if these fundamental constants were even slightly different, slightly stronger, slightly weaker than they actually are in this universe. That's the idea of fine-tuning.
To better appreciate this concept, imagine a machine able to control the strengths of each of the physical constants. If you changed, even slightly from its current setting, the strength of any one of these fundamental forces, such as gravity, the impact on complex life would be catastrophic.
If you increased it by a little bit, no large-scale life forms could exist. Anything that was more than the size of a pea would be completely crushed. So you might be able to get life of a very, very primitive sort, such as bacteria, but you could never get conscious observers.
Now, this is one of a long list of properties in underlying physics that seem to be prerequisites for a universe with life. For example, the strengths of the other forces are all important, the masses of the various subatomic particles. If all of these things were even a little bit different, then life, certainly life as we know it, could not exist.
These forces and constants are another example of the correlation between life and discovery. For not only are they finely tuned for our existence, they can also be understood.
It's remarkable how well the laws work. And not only that, it's remarkable how simple they are. And that also is related to the discoverability of the laws.
Albert Einstein wrote, "I have deep faith that the principles of the universe will be both beautiful